What's up guys, my name's Amir and today we're going to look at some wave theory. So that's velocity, frequency, wavelength, the graphs. We're going to explain all of that to you in a nice short video today. Hope you enjoy it. So today we're going to be explaining the main features of a wave. These are the velocity, frequency, period, wavelength, wave number, displacement, and amplitude. So the velocity is represented with the letter V, and it is the speed of the wave. So the units are meters per second. Frequency with the letter F is how many wave cycles in 1 second, and the units are per second, or in other words, hertz. Period with capital letter T is the time taken for one wave cycle in seconds. Wavelength is represented using the Greek letter lambda and is the distance of one wave cycle measured in meters. The wave number k is the reciprocal of the wavelength, so its units are per meter. Displacement is the distance from equilibrium, and amplitude is the maximum displacement from equilibrium. Alright, so now that we have our definitions, let us see what these mean in terms of an actual wave. So there's actually two ways you can draw a wave. You can draw a wave using a displacement time graph. So with this axis, we'll have time measured in seconds with the y-axis as the displacement. And you can also draw it with a displacement distance graph. So the x-axis here is distance, and the y-axis is displacement. So it's really important understanding the difference between these two waves. This one gives us what the displacement looks like with respect to time, whereas this one actually shows you the physical movement of the wave itself. So you can see this as the x distance and this as the y distance, whereas this is only one axis of distance, whereas this axis is the time. So it's showing you what's happening as time passes. So let's label these graphs with the values that we've just learned. We have velocity. Now velocity actually isn't directly represented in any of these graphs. So let's jump to frequency. So the frequency of the wave is the number of wave cycles we get in 1 second. So if you look at this, between 0 and 1 second, how many wave cycles do we have? We have half a full wave cycle happening in 1 second. So that means our frequency is actually going to be 1/2 cycles every second. Then we have our period. So our period is the time taken for one full wave cycle. So if you look at it, the time taken for one full wave cycle before it starts repeating again is 2 seconds. So we have our period, which is equal to 2 seconds. So we can see that the frequency and the period are actually reciprocals of each other. And this is actually a phenomenon that always happens. In other words, the frequency is always the reciprocal of the period, and the period is always the reciprocal of the frequency. We can actually verify this by looking at the units for period and frequency. So the units for period is seconds. So if we look at this in terms of units, the units would be 1/seconds. And remember, this is the units for frequency. This is what a hertz is. So if you do the same thing with the period, you can see that as well. All right, the next item we have is the wavelength. So the wavelength is the distance for one full wave cycle. So people would often say, you know, the distance between here to here, one full wave cycle. But if you actually look at this axis, this is a time axis. This gives us no information of the distance. So we actually have to use our distance graph instead to work out the wavelength. A common way of doing it is by looking at successive crests to work out the wavelength. So the wavelength here would be this distance there. So let's say we put 1 meters here, this is 2, this is 3. Our wavelength would be 2 meters, the distance for one full wave cycle. The wave number is simply just the reciprocal of the wavelength. So you can't actually see that on the graph either, but the wave number k is just 1/the wavelength. So be careful, because this distance here, even though it represents the exact same thing on this graph, it will represent the period, not the wavelength, because the axis here is the time. So this is telling us the time for one cycle, whereas this is telling us the distance for one cycle. So the wavelength is the distance for one cycle, so we can only use this graph to work out the wavelength. The amplitude is now the maximum displacement of the wave. Now you can see that on the y-axis, displacement is shown both times, so we can actually use either of these to show the amplitude. So the maximum displacement you can see is happening here, and it's also happening here. So this distance here is the amplitude we represent with letter A, and we can alternatively use this graph too to work out the amplitude as well. So that's the distance there, the amplitude. Be careful, the amplitude is the maximum displacement from its equilibrium position. So the equilibrium position is the line in the middle, and the amplitude is its maximum displacement from its normal position. The displacement at any time just represents how far is the position of the point away from the equilibrium position. So we can see at this point right here, the displacement is 0. At this point right here, the displacement is around half of A, and then at this point right here, we have the full amplitude as the displacement. So the displacement is just a way of saying how far are we away from the equilibrium position at any point in time, but the amplitude is the maximum displacement. So these values here are the amplitude. Just don't get confused, because sometimes people will think the entire distance from the top of the wave to the bottom of the wave is the amplitude, but it's not. It's half of that. So we can now look at the important formulas that drive wave equations. One of the things that we didn't look at on the graph because it wasn't there is actually the velocity. Now the velocity is equal to the frequency times the wavelength. This is a really important golden formula that you'll need to remember, as this comes up very, very often. And we can look at it in terms of units and see what it actually means. So remember, frequency means hertz, in other words, per second. And wavelength is in meters, so the units are in meters. Now if we multiply these units together, what do we end up with? We end up with meters per second, and meters per second is the units for velocity. Now as we just saw, we also have frequency, which is equal to 1 over the period. And now if we rearrange this, we can see that the period is 1 over the frequency. You can put the units in here as well to verify that this is true. And we also have the wavelength, which is equal to 1 over the wave number, or in other words, the wave number is also equal to the 1 over the wavelength. Cool, so now with these equations, you can actually solve pretty much every single wave problem that you encounter. The trick is just knowing when to use which one and being able to read the graphical information presented. I hope you enjoyed that video. Hopefully it made sense to you. If it didn't, you can ask me any questions at any time. And in our next video, we're going to be practicing some simple velocity, frequency, and wavelength questions for you guys to practice. So I'll see you then.